Rahim. Assalamu alaikum, dear students. This is our next problem having been chosen from the same book, Modern Physics by Paul A. Tipler. As usual, we first come to its statement. Okay, the energy released in the fission of a uranium 235 nucleus is about 200 million electron volt. Million meaning 10 to power 6. If we convert it in electron volt, then it will become 2006 more zeros, that is 2 with 8 zeros electron volt. Okay, the energy released in the fission of a uranium 235 nucleus is about 200 million electron volt, or 2 with 8 zeros electron volt. How much rest mass in kilogram is converted to energy in this fission? Now we come to its solution. Dear students, in this solution this conversion factor will be used. Okay, which conversion factor? Only last figure. 1 electron volt is equal to 1.602 into 10 to power minus 9 joule. Okay, dear students, here dot is not decimal, this is showing multiplication. Okay, 1 electron volt is equal to 1.602 multiplied by 10 raised to the power minus 19 joule. Using delta E equal to delta mc square, we have delta m equal to delta E over c square. Delta E is given in the statement 200 million electron volt. We can also convert it in electron volt as we have done in the next step, and we know that value of C is 2.998 into 10 raised to the power 8 meter per second. Sometimes we take it as 3.0 into 10 raised to the power 8 meter per second, and sometimes we take 2.998 into 10 raised to the power 8. In both cases our result is almost or perhaps exactly same. Okay, no difference. Next, simplification, nothing else, dear students. This becomes equal to 200 into what we have done here. In place of electron volt we have used its alternate value from conversion factor, which I had shown in the beginning of this problem, that 1.602 into 10 raised to the power minus 19 joule. Okay, 19 joules. Yes, 1 electron volt. Yes, 1 electron volt equal to 1.602 into 10 raised to the power minus 19 joule. So yes, okay, no confusion. In place of electron volt we have used this value 1.602 into 10 raised to the power minus 19 joule per divided by this. After simplification our result becomes this. Actually, dear students, what is going on? This 10 raised to the power 16, when shifted to a numerator, it will become minus 16. Okay, so minus 16 and minus 19 will be added, and these will contribute to 35. However, this 10 raised to the power 6 is plus, so this 6 will be subtracted from 10 raised to the power 35. Okay, so 35 minus 6 29. Okay, so that is why next, yes, one more change we have made. Next, we have used alternate units of joule. Okay, we know that 1 joule is equal to 1 kilogram meter square per second square. Okay, So what we have done, first we have used the conversion factor in which we have converted electron volt into joule. Next we have used alternate units of joule, because we know that 1 joule is equal to 1 kilogram meter square per second square. Okay, by using these alternate units of joule, the benefit of this step will be that meter square per second square will be cancelled from a numerator and denominator, and our result will become 35.65 into 10 raised to the power minus 26 gram. Okay, actually dear students, meter square per second square has been cancelled with meter square per second square. Okay, and we are left with 35.65 into 10 raised to the power minus 29 kilogram. We have when we convert kilogram into gram, kilo means 10 to power plus 3, so 3 number will be reduced from this number, and hence it will become 10 raised to the power minus 29 gram. Okay, it can further be converted in this form, 3.565 into 10 raised to the power minus 25 gram. Similarly, it can also be shifted in various other forms, but that is quite unnecessary. Okay, so we have successfully, alhamdulillah, we have successfully solved our problem, and our answer has become equal to 3.565 into 10 to power minus 25 gram. And this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.